Our next speaker is Mike Lublin from Qualia. He's a software engineer at Qualia who works on the title management system there, and he'll be talking about the tools that they use for developing and deploying Meteor apps. Let's welcome Mike Lublin.
Hi, everyone. I'm Mike. I'm a software engineer here at Qualia. Like Sashko mentioned, we've been using Meteor in production for quite a while now. And today I'm going to talk about some of the tools that we've created to make our lives easier as Meteor developers while developing and deploying our Meteor apps. So first of all, let me tell you a little about what Qualia is. Qualia is a workflow platform for title and escrow companies. So anytime a house is bought or sold in the United States, there are these people that do all of the processing work, all of sort of the back office work to make sure that that transaction gets completed smoothly. And the people that do this work are called title and settlement agents. And we make workflow software for their very specific workflow. And so we've been building our application in Meteor. And the core of our application is handling a lot of data entry, doing a lot of different calculations on that data, managing documents related to the real estate transactions, managing contacts for the real estate transactions, things like that. So some of the challenges that we have with Meteor and with our application in general, we have very large Mongo documents. So the main collection that we have in our application is called orders. Each order represents a single real estate transaction. And those transactions have lots and lots of data that users can enter in about them. So these are things like the purchase price of a house, the loan amount, but also things like the property address, but also way more specific things like how much was the pest inspection fee on this real estate deal. So very, very specific things. So our order schema has on the order of like thousands to tens of thousands of keys. So our objects are just very large. And that's led to a lot of performance issues that we've had in the past. We also need to have a very snappy, a very reactive UI. So our users are power users. These are people that sit and use our application all day, and they use it for everything that they do. And these people, when they're using our app, they need to get things done. They're not just there to like mess around. Like they need to get things done quickly. And so if things are slow, if there's lag, if there's problems, that's like a big problem for our users, and it's a problem for us. And then finally, we maintain a lot of production Meteor deployments. So the way that we sell our software is that we will sell our software to a title and escrow company. And when we do that, we'll deploy their own Meteor application to them, just for them. And this has some nice properties. One is that each of our Meteor deployments is completely isolated from the other ones. So they have their own Meteor app, they have their own database. So there's no communication between deployments, which is what we want. And it's also nice because this provides a natural horizontal scaling of our deployed Meteor apps, in that every time we add a new customer, we're adding another Meteor app. So there's not like one main Meteor app that's getting all of the load from all of our deployments. But the tricky part about this is that this means we don't have to just maintain and deploy updates to one deployed Meteor app. It means we have to do this for many, many production deployments. And so we've had to spend a lot of time thinking about how to manage and how to make our lives easier so that we can easily deploy code updates and monitor many, many different Meteor deployments. So today I'm going to talk about a few of the things that we've built out to make our lives easier in this respect. So I'm going to talk about some of the Meteor packages that we've developed internally. Most of these are internal packages. We haven't open sourced them, but we're actually in the process of open sourcing a lot of these packages. So some of our packages are just drop-in replacements for existing Meteor packages that are out there that have performance optimizations or are specialized for our specific business needs. So we have our own internal packages, for example, for front-end components, for file management, things like that. And some of our internal packages are specific for our particular business needs. And so I'm going to talk about one of our packages that we have that allows us to automate a lot of the calculations that we do in our app. And then secondly, I'm going to talk about how we've managed to automate our build and deploy systems using Docker, Rancher, and Concourse. So first, I'll start with talking about our Meteor packages. So one of the things that we realized early on was that we needed an easy way to have certain values in our schema calculate based on other values in the schema. An example of that is, let's say we have some price per time period, and we have a time period. We'd like to be able to calculate the total cost over the whole time period by multiplying two values together. So I'll show you an example of that. So the way we solve this problem is we've actually come up with a very declarative format that we can define for each value in our schema, a list of other fields that field depends on. And then we can provide a function to run when any of the fields changes that field depends on. The function will rerun and recalculate the value of this particular field. So let me give you a quick example. So let's say we have three values in our schema. One is a homeowner's insurance cost per month. Another is a months of homeowner's insurance purchased. And a third is the total cost of the homeowner's insurance. So if a user enters in $10 a month for 12 months, we'd like to be able to automatically calculate, okay, the total cost is $120. So how does that look in our schema? So we have these three fields. The insurance cost per month is a number. The months of insurance is also a number. And the total insurance cost is also a number. But then here we can define a list of fields that this current field depends on. So we're saying, okay, the total insurance cost depends on the insurance cost per month, as well as the months of insurance. And then we have this DepValue function. And what this does is this will take the values of the other fields in the schema and produce the current field in the schema. So this is saying, okay, let's get the value of insurance cost per month, and let's get the value of months of insurance. And we can calculate the total insurance cost by multiplying those two together. And what's cool about this is that this is a very declarative way for us to specify a lot of our business logic. And actually, a lot of the business logic in our app is written this way. And it makes it really easy for us because we don't have to scatter a lot of the business logic in different places. It's all contained within the schema itself. So how is this implemented? So the way this works is that we calculate a dependency graph between different fields at runtime. So each field can declare a list of other fields that this field depends on. And so we know we can run essentially a topological sort on those field dependencies to determine for every field which fields depend on me. And then before every collection update, we just find all the modified fields in that update, and we can use the dependency graph to determine which other fields we need to recalculate. And like I said, this is cool, and this is really helpful for us because a lot of our business logic is implemented this way. So this is one example of an internal package that we've built out, and this solves a pretty important business logic need for us in that we need to have certain values in the schema calculate based on other values. Other packages that we've built out internally have just replaced existing Meteor packages. For example, we have our own input component system. So we used to use Autoform, but we actually dropped Autoform and built our own replacement for that because we were having issues with a lot of the UI lag. Because like I said, our documents are so large, Autoform does a lot of document clones, and that was just too expensive for us, so we had to build a drop-in replacement for that. So now let me talk a little bit about our deployment pipeline. So our dev environment is run entirely in Docker. So when we're developing locally, we run our Meteor app within Docker, and then we also have a host of microservices that we run in Docker. So our core application is a Meteor application, but then we have around a dozen different microservices that do very modular tasks where we like to offload work from our Meteor server. And so we've built these microservices, and these are all run using Docker and Docker Compose. And then our production environment is very similar to that. So each deployment is also run using Docker and Docker Compose in AWS. And there's one stack for each customer that we have. So it's a very analogous structure to what we're running in dev. Each deployment gets their own Docker Compose stack, and we're running one of these for each of our customers. And this is all sitting in AWS behind a load balancer. So how do we manage all these deployments? How do we keep them all up to date with code and deploy new code to them? So for this, we also have a very sort of declarative way of saying how our infrastructure needs to look. So we have a production repo that keeps the state of all of our deployments in a few very key files. So we have one file that's a deployments file that just keeps a list of all of our deployed Meteor apps and associates with each one a deployment track. where a deployment track is just like a grouping of deployments that all gets deployed code at the same time. The second key file that we have is a tracks file, and this file associates with each deployment track which GitHub release number should this track currently be on. So we have these two files that sort of specify the state of our infrastructure as it's supposed to be, and then we have a concourse deployment pipeline which knows how to take that specification of our infrastructure and make it be in AWS. So that we as engineers, when we're deploying new code, all we need to do is create a new GitHub release and then update a track with the new release number that we just created, and our concourse deployment pipeline will take care of the rest. So this makes our lives really easy. So let me show you a quick example of what our files would look like in our production repo. So the two important files that we have are this deployments file and this tracks file. So this is just an example. So this is saying, OK, we have these 4 deployments, QA1, QA2, QA3, and QA4. And QA1 is on this alpha track. QAs 2 and 3 are on this beta track. And QA4 is on this stable track. And then in this other file, we're associating with each track which GitHub release number is that track going to be on. And so this is saying, OK, this is on version number 2.280 pre-3. And so all we need to do when we want to upgrade a certain track is just change this file, push it to GitHub, and then our concourse pipeline will do the rest. So this concourse pipeline sounds pretty magical, so what does it actually do? So we have 2 key pipelines. The first one is a build pipeline, and this is pretty straightforward. So this is anytime we create a GitHub release on our repo, this concourse pipeline is listening for releases, and whenever there's a new one, it's going to build and push Docker images for all of our services at that specific tag. So it'll check out our GitHub repo at that tag, Docker build each image, and then push that all to Docker Hub. That's pretty straightforward. And then the second part is that we have a deploy pipeline. So once all the images, or once all the containers and images have been pushed to Docker Hub, all we have to do is go in and update the release number associated with the track, like I said before. And what that's going to do is that Concourse is listening for code changes in these files, and it knows, OK, if the release number has changed on this track, I need to go to each of these deployments and bring up a new stack in Rancher with the images specified in the track. And so what it'll do is it will bring up a stack for each deployment in parallel, and then wait for certain health checks to pass on each of the deployments. And then when it does, we switch the load balancer to point to the new stack, and then we bring down our old stack. So all of this happens very quickly, and it happens with essentially no downtime. So what's cool for our customers is that we're able to deploy code with essentially 0 downtime. So if we needed to, we can deploy code midday if there's some critical bug or something that we need to fix. So really quickly, I'd like to talk about a few cool things that some of our developers have been working on recently. So one really cool thing that we have, I'm not sure if other people in the Meteor community have, is that we're able to Meteor shell into our deployed production apps. And this is something that we were corresponding with MDG about for a while to figure out how to do. And this is something that's been extremely helpful for us to be able to debug issues. So actually, it's pretty simple to get. It just requires modifying your production Dockerfile a little bit. So this is essentially the Dockerfile that we use in production. I'm not sure if you're able to see this, but this is all available in our GitHub in this Meteor Dockerfile repo. So essentially, all you need to do to be able to have a Meteor shell in production is that you need to copy parts of your .meteor directory into your Docker container that's running your Meteor app. And then you need to set this Meteor shell dir environment variable. And then from here, to be able to run a Meteor shell, all you have to do is SSH into your Docker container, install Meteor, and then go into this specific directory and run Meteor shell. And this is incredibly useful for us. We use this pretty frequently to like poke around in our deployed production apps and see things that are going on. So I hope you guys are able to make use of this as well. And then secondly, this is something that we just worked out several weeks ago, but we figured out a way to get instant client-side reloads. This is something that one of our engineers, Lucas, has been working on, and it's super cool. So I'd like to show you a quick demo of how this works. So this is a version of our app running in dev. Normally, our front-end reloads take more than 10 seconds. It can take 15, 20 seconds, depending on the changes that are happening. But we figured out this way to get essentially instant reloads. So let me show you an example of this. So here I have this template HTML file pulled up. We use Blaze. Currently, this package only works for Blaze, although it would be easy to set up for some other, like React or something like that. So currently, I have this page pulled up on our app. This is called the basic info page. This has some basic information about a particular order in our system. So we can see here we have this basic info header. And I have this template HTML file pulled up here for this page. So like one thing I could do is I can go and modify this text and say hello. And without saving anything, it immediately shows up here in our app with no saving. I could also like delete this whole header. And now the header's gone. I can bring it back. I can duplicate the header. Now we have 2 headers. How? I will get to that in a second. It's not magic, although it does seem like magic. So this is super cool. So this works currently for template HTML files as well as JavaScript files and CSS. And we're actively seeking community engagement to help us build this out, because this could work for any type of code, essentially, that could be just evaled on the client. The way this works, essentially, is that we set up a server-side route on the Meteor server that is able to accept files, like post requests that have a file in the body. And we've set up a text editor plugin so that whenever there's a code change, this sends a post request to the Meteor server. And then depending on the file type, the Meteor server is going to make some slight adjustments to the code so that it can send the code directly to the client, and the client can just eval that code, and then it will do what it needs to do. So for example, in the case of the HTML file, it just needs to interact with sort of Blaze and the templating system and re-render the page that way. And it does slightly different things depending on the file type. But this is something that is like extremely useful, because really any type of code that can just be evaled on the client could be potentially set up this way. So right now, the way this is set up is that this can either be run by installing a code editor plugin, and we currently have plugins for Sublime Text and Spacemacs, or you can run an in-browser editor that is set up to send post requests to the Meteor server when changes happen. So I actually have a link to our GitHub repo here. It's Qualia Labs/reval. So you guys can check this out as well. There's a getting started area that tells you how to set this up if you guys are interested in checking it out. And I highly recommend that you do, because this is I think really cool. So that's all, and please check out our GitHub repo. Our Meteor Dockerfile is on there, as well as our reval package. So thank you.
Thanks, Mike. That's some really cool stuff. I'm sure people have questions.
So, long story short is that if we have a deployment and there is something wrong with the HTML, I assume it doesn't work for JavaScript, just HTML. And if I want to modify a bit of HTML for all my deployments, that is possible.
So
I know it's not something that you do in production, but still.
Right. Yeah, so that's a good question. I guess, yeah, this could be set up to run in production. I don't think there's any reason that it couldn't be. But currently, it's really set up for dev. And it seems risky to set this up in production, but I guess you could. Yeah. Yeah.
Hi, a little bit off-top question. What do you use for input fields in your forms? I saw.
Yeah, that's a good question. So, like I mentioned before, we've actually built our own version of Autoform. So we have our own input fields. We have a package for this. It's called Perform. It's like Autoform, but more performant. And so it's nice because we've built it like with a focus on performance, like I said, because our objects are so large, we can't do a lot of document clones. One of the key features of Perform is that whenever users type into an input field, we immediately update the UI before we even push our changes to Mongo or to the server, because that way it's incredibly responsive to our users. And we also do our own input styling using semantic UI. So our whole site is styled using semantic UI. And by having our own input package, we can control the styles on all of our inputs as well. So I can show you really quickly, like this page has a lot of different input styles. So this is like a date input field. This is like a text input field that's formatting money. We also have like drop-down fields and like search inputs. So like I can search for a particular user, things like that. This is an internal package. I think we'll get around to open sourcing this at some point. I'm not sure if there's a timeline, but yeah.
All right. Unfortunately, we're out of time for questions, but let's thank Mike again for his really great talk.